In this video, I'll go over the answers to classwork 8. So classwork 8 kind of has some background information first. So it says, all of our analysis depends on the assumption that consumers have preferences and consistently choose the best bundle of goods they can afford. If consumers do not behave this way, our estimates of the indifference curves become meaningless. So how can we determine if consumers are actually following this maximizing model? The answer is warp, the weak axiom of revealed preference. If x1, x2 is directly revealed preferred to y1, y2, and the two bundles are not the same, then it cannot happen that y1, y2 is directly revealed preferred to x1, x2. So here's my example in this picture. This would be a violation of warp. Consider first the flatter budget line. In the flatter budget line, I have a dot here, which means that x1, x2 is the bundle that was chosen by the consumer. Notice that y1, y2 is affordable at this set of prices and this income, and so x1, x2 would be directly revealed preferred to y1, y2. But then when prices change, I'll use orange here, prices change to this, and now this dot indicates that y1, y2 is now the choice for the consumer. The problem is that x1, x2 is still affordable at these new prices. And so that would mean that y1, y2 is directly revealed preferred to x1, x2. And so we get, that x, not thick enough, x strictly preferred to y, but then also y strictly preferred to x, which is contradiction. So that is a violation of warp. And then here I just explain what I just said. So I'll skip over that. So this situation suggests one of two possibilities. If there's a violation of warp, either the consumer is not selecting the optimal bundle they can afford, or so they're not maximizing, or there are other changes in the choice problem that we have not observed. So we kind of make the assumption that things are stable in, between the consumer choosing this and the consumer choosing this, but that might not be holding. In any case, this type of violation does not align with the model of consumer choice in a stable environment. So finally, here we get to the question. When prices are P1, P2 is 1, 2, the consumer demands X1, X2 is 1, 2. And when prices are Q1, Q2 equals 2, 1, the consumer demands Y1, Y2, 2, 1. Is this behavior consistent with the model of maximizing behavior? So what we're checking here is warp, right? So here I'm going to draw, let's see if I can get a little grid on here, that'd be perfect. Nope. I don't see my grid, so I'll just draw something here. Okay, so let's see. I guess the first thing I like to figure out is what is the person's income. So when prices are P1, P2, 1, 2, consumer demands 1, 2, which means that their expenditure is 1 times 1, which is 1, plus 2 times 2, which is 4, to be a total of 5. Their income is 5 here. And P1 is 1, so if they spend all of their money on good 1, of X1 here, X2 here, they can afford 1, 2, 3, 4, 5. They can afford 5 units. When prices are this, the consumer demands this. Let's check to see if, oh, sorry, I didn't draw a budget line here. We have to do this one here over here. So if we spend all our money on good 2, how much good 2 can we buy? We have an income of 5, so we can buy 2.5. So here's 1, 2, 2.5. It's right here. Connect the dots to make the budget line, and then put our preferred bundle here. Label that 1, 2. So that is X1, X2. I'll just label that X. And then let's go on to change colors, and we'll go on to the Q price regime. Let's check that see if our income has changed. We buy 2 units of good 1, at a price of 2, so we are spending $4, and then we're spending $1, because that's 1 times 1. So income is still 5, and if we spend all our money on good 1, it has a price of 2, so we can buy 2.5. If we spend all our money on good 2, we can buy 5 of them, because it has a price of 1 now. So 3, 4, 5. This, connect the dots to form the budget line, and that's where we're at. And then so the consumer demands 2, 1, 2, and 1. So that is point Y. Label that Y. So we want to check warp. Is this behavior consistent with a model of maximizing behavior? So let's start with the X budget line over here where we chose X. Was Y, was X chosen over Y? Yes, it was, because Y is absolutely still affordable in this budget line. So X was chosen over Y. X is directly revealed preferred over Y. So X is strictly preferred over Y. And then when prices changed to the green line here, what happened? We chose Y, but X was still affordable. So Y was chosen over X. And so we have a contradiction. And this is a violation of warp. Violation of warp. And is this behavior consistent with a model of maximizing behavior? I would say no, it is not. All right, let's go on to part B. When prices are this, a consumer demands this. When prices are this, a consumer demands this. Again, we're going to check to see if we violate warp or not. So similar as just like before, I'm going to draw a picture, and first I'm going to check what the income is. So $2, spent $2 per, and we bought 1 of them, so that's 2, plus $1 per, we bought 2 of them, so 2. Now our income is 4. Income's 4 here at this first price. And the prices are 2 for good 1 and 1 for good 2. If we spend all our money on good 1, we can buy 2 of them, so we have an income of 4. So 1, 2. And then if we spend all our money on good 2, it has a price of 1, so we can buy 4 of those. 1, 2, 3, 4. So that's our first budget line. And how many do we decide to buy? 1, 2. Here we are with bundle X. And then let's change the color to pink now. When prices are this, we get this. Let's check to see if our income seems to have changed. $1 per, we buy 2 of them, so that's $2. Plus $2 per, we buy 1 of them, that's 2. Income is still 4. Let's draw the budget line. When we spend all our money on good 1, we can buy 4 of them because they're price 1. So 1, 2, 3, 4. And then when we spend all our money on good 2, we can buy 2 of those. So here's our budget line there. And then we decide to buy 2, 1. So 2, 1, here we are here. This is bundle Y. So is this behavior consistent with warp? Let's see. Is X chosen over Y? When we're here at this budget line, when we're choosing X, was Y affordable? No, it was not. Y is not affordable under that budget line. So X is not chosen over Y. And now let's flip it around. Was Y ever chosen over X? When our budget line was that, X was not affordable. So Y is not chosen over X. So we have no idea, is X preferred over Y or Y preferred over X? No idea. So this does not violate warp. We can absolutely draw well-behaved indifference curves, which rationalize these choices. If x is preferred over y, we can draw indifference curves that look like that. They would look something like that, right? Indifference curves like this. Or we could also back up and draw the case where y is preferred over x. The indifference curves would look like this. Y over here, and then x over here. So this is absolutely consistent with the model of maximizing behavior. Versus, let's look to see, I'm curious, would we be able to draw indifference curves where x is preferred to y and y is preferred to x? Certainly not. So the indifference curve where x is preferred to y would look like this. But then the indifference curve where y is then preferred to x would look like that, which create, if you can see that there, indifference curves that cross, which are, that's one of the first things that we learned about indifference curves, that they cannot cross. All right, so let's go down to part C. Question C asks, in part B, which bundle is preferred by the consumer, the X bundle or the Y bundle? And that's what we just discussed right here. We have no clue. So kind of a trick question. You'd say, don't know. We have no evidence about whether X is preferred to Y or Y is preferred to X, because none of them are ever chosen over the other. And so that's what I'm looking for that question. Hopefully this helped you understand classwork 8.